All right, so to the shock and amazement of absolutely nobody, it's just the three of us. Um, so what I'm going to do, and I'm just for anyone watching this on YouTube, hopefully, what we're going to be doing for the next 4 nights, 4 nights, yeah, is just covering the exams in detail. We might add another study session on top of that for. We might want to redo the study guide for the first exam, just because it's been so long since we've done that material. That's the stuff that's going to be the most muddy, maybe. And then, of course, the stuff from 10.1 and 10.2. So we're looking at 5 study sessions. Today's Tuesday. Tuesday would be first exam. Wednesday would be second exam. Thursday would be third exam. Friday would be fourth exam. And then Saturday would be 10.1, 10.2, and maybe the study guide from the first exam. And Greg took off. Okay, let's just us now. Can you read the text on my screen?
Yeah.
Okay, so let's just do it again. Or welcome back, sir.
Okay, I'm getting a bunch of blue screen errors, so I'm trying to figure out what's wrong.
No worries.
I might get kicked out.
Okay, so our first question from exam 1. Every positive number has a positive square root. And as we know that that word every in that sentence indicates that it is a universal statement, right? And I like the symbology of that. So, if I were writing this on a test or something, I might put a little note to myself that it's for all x, like I have there. So part A is we're just going to be rewriting the sentences to keep the same meaning. So, and I'll actually write out the original here. Every positive number has a positive square root. Okay, so Greg, our sentence starts with all positive numbers. Can you give me an example of how we could finish that sentence so that it keeps the same meaning? Can you hear me, Greg?
Then I'll go ahead. I'll go, Joe. For all positive numbers,
So
there's
it just starts with all positive.
Yeah. Okay.
Right.
Well,
So we're go ahead.
For A, right?
Yep.
Yeah. So it says all positive numbers blank has a positive square root. We can almost repeat the same thing.
Exactly. So, like you were saying, have instead of has, it would be have.
Yeah.
A positive square root. And so what I'll be doing with these types of problems is let's come up with a couple different examples, because the cool thing about these kinds of problems is that there's not necessarily one answer that's right and everything else is wrong. So you could also say something like, well,
I could say all positive square roots have a positive number.
or if the square root is positive, then the number is positive, stuff like that. But so we'll just do B. I guess that's really this answer that we have in blue is probably the only answer that really applies with slight modification. All right, so for any positive number x, sorry guys, my handwriting sucks tonight. There is blank for x.
Well, since I'm next in line,
Right?
I'll say
it's a Sebastian show.
Yeah, there is a positive square root.
Right.
Or there's a positive square root, yeah. Good.
And so, and this was what I was getting at. So I think that's a perfectly acceptable answer. But let's get another one. There is I could also say something like square root of x is greater than 0. So that seems like I'm talking about two completely different, like that looks like surely those two things aren't related, but it's basically saying the same thing. And both of those would be acceptable answers for the exam. And finally, C, for all positive numbers x, there is a positive number y such that blank. So what would you put there, Sebastian?
For all positive number x, there's a positive number y such that y has a positive root. Can I say that?
You could, I mean, slight modification, I might say you could, y has a positive square root. Excuse me. When you just said root, that could be like the third root, fourth root. So when you say has a positive square root, it's specifically the square root.
Yeah. Okay.
And I really don't think he would take points off. But so again, as sort of the example before, we don't necessarily have to keep in the realm of English language for a problem like this. We can just say square root of y is greater than 0, or square root of y is positive, stuff like that. So again, the cool part about this problem is there's many different sort of ways of thinking about it and answering the problem. Okay, that was number 1. Okay, number 2, I have to do some editing here. There's an element of. This is a pain in the butt. All right. I find it interesting that it doesn't know what to do when you copy these symbols.
Oh, is it the braces that it's not registering?
And the subset symbol and stuff like that. So I just have to, so that anyone that's not following along with the test in their hand knows what we're doing. Sorry for the wait, guys. Just have to grin and bear it. All right. Oh, no, that was wrong. Damn it.
Oh, we're doing subsets and proper sets. Okay.
Yeah. Okay. So there we go. So we're going to answer the following question. It's 5-part. As long as you can read it, I'm not going to sit here and, I don't think it's necessary to rewrite everything,
Yeah.
but I'll just write little notes here, just as a reminder to, I don't think you'll need it, but, just a small, that's why we're doing this, is to sort of, oh yeah, I remember that. So this simple means is an element of. This simple is a subset of, and this symbol is a proper subset of. Okay, so is C an element of ABC?
Yes.
Sure is. And that's because we can find what's on the left-hand side as an element of this set. Now, is this set containing B an element of A, B, C, or the set containing A, B, and C?
I would say no, because the B is a set
That's right.
element.
That's correct. And so for that to be true, what would have to be changed here would be braces around this B here.
Yeah.
Welcome back, Greg. Let me know when you got your computer problems squared away, so I'll start asking questions of you too, Greg. If that's okay, sir?
I'm on my phone right now. Yeah.
Okay. All
All
right.
good.
So is A subset of the set containing A? Sebastian?
No.
No. So this would be true if this was the element of symbol, right? A is an element of the set containing A, but we're using the set or subset symbol, and A itself is not a set. All right. So now we're being asked the set containing A is a subset of the set containing A, B, and C.
You know, it's been a while, but I want to say yes.
You are correct. And so how we can think about this, so just to, let's take a quick little break and just talk about sort of what this means. So how am I gonna write that? When I talk about an element of, what I'm really talking about here is I'm gonna have a set, right? Let's call it A. And it's gonna have whatever, right? And when I ask is one an element of A, what I'm asking is, can I find that as a singular element inside the set? That's what element means. It's part of the list. What these kinds of questions do to try to trip you up is, well, what happens when I have braces around that one? And I'm asking, is an element? Well, one is not a set inside the set. It is an element. There's no sort of circle around this. Right? That's what this is asking. Is this a set, a division of A? All right. So in the same way, when I'm asking about subsets, here's what I'm really asking. A, 1, 2, A, B. All right, so I'm asking, is B a subset of A? In this case, that would be true because there's sort of that circle around B in 2. It's a group within a group. Okay? So going back to the original problems, every element found in the left-hand side is also an element found in the right-hand side. So you're correct, this would be yes. And then just to remind you, how I view these symbols, this sort of, is a subset of, it's a subset, it's a proper subset, it's a super, he won't do that, I don't think, right? Sort of think about this as less than or equal to, and this one as less than, right? So when we see the symbol subset, it means that the two sets could be the same, right? You know, I'm not going to sit here and try to come up with an example, but it would look like this. Damn it. Right, so I could have this. Right? And in this case, B is a subset of A. What's important to note here is that B is not a proper subset of A. And that's because for it to be a proper subset, there has to be an element in A that is not in B. So that's where that less than or equal to or less than sort of helps remind me what it is. Okay? All right, so our last one here. Sorry, I'm sure you know this. It's just, I don't think it's a bad thing to remind ourselves. Okay. So we're being asked, is the set containing A proper subset? Again, it's different than the subset of A, B, and C. What do you think, sir?
I still think it is.
It sure is. Well, so what are the two questions we're asking? We're going to go through every element in the left-hand side, and we're going to look for that element in the set on the right-hand side.
Right, because the set on the right is bigger, has more elements.
That's right. And so that would be the other part of a proper subset, is that there are elements on the right-hand side that are not in the left-hand side. So yes.
But if you flip those around, it would be false.
Correct. Or if they were even the same, it would be false.
Yeah, right.
Cool. All right. Number 3. Okay. Let me just correct the problem here. So this is just asking for the cross product. Now, help me remember, because it's been a long time since I took statistics. When you have every possible, have you taken statistics, Sebastian?
No.
No,
I
okay.
have.
Only math class I've taken.
When you have I know there's combination and permutation. Where is it where it's every possible?
Combination is order doesn't matter. Permutation when order matters.
Got it. Okay, so this would be, so cross product is just the permutation then, okay? So we have,
Well, cross product would be combination because I don't think the order matters. Cross product.
sure it does, because so xy is not the same as yx.
Because remember when he was talking about you can do cross product and you just have to find every combination multiplied. Maybe when it goes x equals y.
Let's not, yeah,
Oh,
I don't want
Cartesian
to, that's what this is, right? Cartesian product or cross product. It's the same, that's the same. Sorry, I was using, yeah, you're right. He called this Cartesian product. All right, so x is equal to 0, 1, and 2. And y is equal to 5 and 7. And so A is just finding x cross y. And so all we're going to do with this is we're going to put every combination of x with every combination, or I'm sorry, we're going to find, basically it's going to be the ordered pairs for every combination of the elements in x with crossed with the, I'll show you, it's hard for me to word what I'm trying to say there because I'm not sure if it's combination or permutation. So I'm just going to start with 0, right? Actually, let me do it this way. So it's a set. Don't forget that part. Cartesian product is always a set, and it's always ordered pairs. Right? So how I tend to word this is I start with 0, and I'll pull my first element from the second set. That's 5. Right? And then I'm going to do the same thing. I still stay with 0, and now I'm going to do the second element from y. That's all the elements from y, right? 5 and 7. I'm going to put a little comma there, and I'm going to drop down. I'm not going to keep writing to the right. My trick here is I'm just going to now, instead of doing 0, I'm going to do 1. And I'm going to use the same element I have above me. So 1, 5, 1, 7. Now I have one last element to start with for x. It's 2, 5, and 2, 7. And don't forget to end with your brace. That's how I find every this is an easy example because there's only 3 and 2. But 5 and 7, and it can be kind of, you can start to get worried that, well, what happens if I miss one? So you have whatever system you choose to get all of them, just stick with that. Okay. Okay. So B would be y cross x. And so what would that be equal to, Sebastian?
Oh yeah, we could go the other way. So we would go 5051.
I'm just going to write exactly what you're telling me.
Okay, then we're gonna go 52.
So yeah, I'm sorry, I'm being not kind of a little jerkish, but don't forget to start with the set symbol,
Yeah.
the brace,
Yeah.
and then it's order pairs. Okay.
Okay, we're gonna go with 70. We're gonna go with 71, and then 72.
Perfect. Good job. And then this is just x crossed with x.
Oh, okay. Do this one too.
Yep. So it's, I'm
Well,
sorry.
it's kind of hard to do 3 in my head, but I can do it.
It's a sit, but it's literally the same process, right? We're just gonna.
Yeah.
So
So
that.
we're gonna
Go ahead.
0 0 with the
Yep.
braces. And we're gonna go with 0 1, 0 2.
And now, and so
yeah.
what I just pointing out to you, this is why I sort of use this like sort of columns and rows idea. In my world, all my thinking is done. I'm a copying monkey, right? Because all I'm going to do is I'm going to copy each of these order pairs twice, one for one and one for two, right? So I know it'll look like this. This is harder to write than you think.
It's nice. That's organized.
Right. So what I'm pointing out to you is when you have sort of this structure, when you add the structure to it, I don't have to think anymore. I know that there are 3 elements, so I need 3 rows. So I'm just going to do the same thing again. I don't do it in this way, but I just want to sort of show you the mentality of this, right? So I know that that's all of them, and all I have to do is fill in the blanks. But what is my second element in X? 1. So I'm just going to put 1, 1, 1. And then 2 is 2, 2, and 2. I know for certain that every permutation or whatever the right word is, every single element, every single combination is taken care of there. Okay. All right. Define this for. From starting, hopefully going forward, what I'm going to do is I'm going to do this ahead of time, so we don't have to sit here and you guys have to waste your time just watching me have to reformulate these problems. All right. Oops. Okay. Okay, so we're defining a relation f from the real numbers to the real numbers as follows. For all ordered pair x and y, and the real cross with the reals, x comma y is an element of the function f, means that x squared is equal to y. Okay. And now we're being asked if these ordered pairs are, at least in this first example, we're being asked if 2 comma 4 is an element of f. And then we're being asked to explain our answer. So you can't just, throw a dart at a dartboard. So just as a reminder, 2, 4 is the x comes before y. and that's defined here on the second line. So we know that x is 2 and y is 4. So I'm just going to plug that into our formula. 2 squared is equal to 4. And we're testing if that's true or not. Well, 4 is equal to 4, so we're good. So yes. And I would even write it, on the exam, here's how I would write it. I would say yes, and then the ordered pair 4 is an element of F. That's precisely how I would word it on the test. Okay. B is 4 comma 2 an element of F. So how would you do that, Sebastian?
When there's an x, I plug in 4.
Yep.
So 4 squared is 16, which does not equal 2.
So I wouldn't necessarily do it in that way. I would put like the question mark with the over the equal sign. I would just plug it in first into the equation.
Oh, okay.
You know what I mean? So you don't get like this is a really simple equation. Like I mean, in the future, like you're doing diffie-q, you know how hard it can be to track variables and stuff like that. So I'm claiming that we're asking the question whether 4 squared is equal to 2. Well, you know it's not because 16 is not equal to 2. So how would you word the final, once you do that work or you show that work, how would you word the answer on your test?
I would say no, that the ordered pair 4 comma 2 is not an element of F.
Perfect. Good job. All right. And my least favorite, I hate this notation, but we keep seeing it, so we have to deal with it. So we're asked if -3 is related to 9 through the function f. That's what this means. And so just to remind you, the very first thing, if this to me can be confusing. I don't like this format. I feel like I'm going to miss something. So if you're not absolutely sure what you're doing, rewrite the problem so that you have -3, 9 is a member of F, right? These two statements are identical. Okay. Anyways, I'm sorry, Sebastian. What would you write here?
Put -3 in parentheses squared equals 9, and put a question mark here.
And so -3 squared is 9.
9 equals 9, and I would say yes. The ordered pair -3 comma 9 is an element of.
You could do that, and you'll be perfect. I promise you, you get 100. I just want to show the other way of running this. So you're right. What I was commenting before is if this worries you, like, am I going to miss a negative? What is what? Take the extra literally 5 seconds to rewrite it this way so that you know that you can do this problem. This might be like, oh, what's going on with that? Right? So the right way to word this, I'm sorry, is parentheses -3 relates to 9 through F. And so if the answer was no, you would just put slash through the relationship variable name. But it's true, so we're good. All right, finally is 9 related to -3 through F. It's supposed to be a 9. Okay. Yeah, you have the right, you know what you're doing here. So it's just 9, we're asking 9 squared is equal to -3. Well, 81 is not equal to -3. So the answer would be no. 9 does not relate to -3 through F. That's how you would write it on the test. All right. All right, so while I'm doing this, just to remind ourselves, when we're talking a relation, what's the difference between a relation and a function? Do you happen to remember?
What I remember is a function has to pass the vertical line test, and a relation does not.
That's not necessarily. It can, right? But it doesn't have
But
to.
it can fail it as well.
Right, exactly. And what's the other? So there's two components. There's two things that make a function special over a relation. You got one of them. It has to pass the vertical line test. Do you happen to remember the other one?
Is it also that it has to be a one-to-one function? It has to one input has to go to one output.
That's what the vertical line test is.
Yeah. Okay. So then, yeah, I don't.
Sure, that's what. Yeah, I'm glad I asked. So the two parts of this is every element. Again, I'm asking this because this question deals specifically with functions. Every element in the domain, which is normally our x when you're thinking about x versus y in domain, is assigned an element in codomain. So, so what is that really? I mean, this is sort of a bunch of mumbo jumbo things. So let me just draw out what I mean by that. So this is my set. Oof, wow. I wish I could draw.
I come back for that. Really, Joe? Come on.
It's all right. I was going to make an inappropriate joke, and then I realized I'm recording this, so I better not. Okay. So A, B, C, and D. So again, this would be, we're trying to define a function from A to B, right? 1, 2, 3, 4, and 5. Okay. So when I talk about every element in domain, I'm saying I'm not missing any element in this would be my domain. So for instance, that's not a good example. Yeah. So B goes to 4, C goes to 2, and D goes to 5. This would be a function because every element in A is assigned in B, and there is a unique, the other one, which we'll talk about the vertical line test, is, how do you word that? No two
All right. Sorry, I'm actually back now.
element in domain are assigned the same element in codomain. And so what I mean by that, sorry?
The horizontal line test is what makes it a one-to-one. I just remembered.
That's right. Yeah, it doesn't have to be a one-to-one to be a relationship.
Yeah.
Right. So I know what you meant.
What is this question asking, Joe? I'm sorry.
Well, I was just recovering because it's been a long time since we talked about the difference between a relation and a function, and I'm concerned that one of the problems on the test will be, is this relation is this relation a function? So I don't want it to be, we forgot what it is. So this would not be a function because more than one element in the domain is assigned the same element in the codomain.
Right.
Just again, this is just trying to remind ourselves. Okay, so getting back to the problem. All right, so define functions f and g from the reals to the reals by the following. For all x in the reals, f of x is equal to x minus 3 squared, and g of x is equal to x minus 2, x minus 4 plus 1. And we're being asked, does f equal g? Right? And so
in order to do that, sorry, I'll probably do this a little bit just to see if I remember even.
that's
So you're
fine.
going to try to break up f so that it equals g. So you're going to do x minus 3, and then you're going to
Right, so I'm going to expand everything.
2, x minus 4. Yeah.
Right,
Huh.
so this will be x squared minus 6x plus 9. I should not have done that. Whatever, f of x equals. And so g of x, I'm going to do the same thing here. Actually, all right. This would be x squared minus 6x plus 8 plus 1. I can combine the 8 and 1 here.
Mhm.
So this is x squared minus 6x plus 9, which is the same
Right.
here.
And that's it. Gotcha.
And so, yes, it is. Cool.
Yes.
Very cool. Yep.
Okay, so we're being asked to generate a truth table to determine if these are equivalent statements. And so just to remind you guys, it's been 3 months maybe since we've played around with these symbols. So I just want to remind you what they mean. So this symbol means and. And the reason why I'm doing this is because I think most people in our class are either taking intro to programming or have taken intro to programming. So we know what this means. Or I feel like the symbol, it may be foreign to us, but the Boolean logic of an and statement, we sort of know. So it's literally the opposite of that. It looks like a V. Is or. The arrow means if, or it's condition. Well, if then. The double arrow is if and only if. Oh man, I messed it up. And finally, the tilde is not. Okay. So I don't want to do this on my own. So Sebastian, how would you? I'll start drawing it once you tell me. What would be your strategy for dealing with this problem?
Sorry, just stepped away for a second. I was grabbing my phone to take a picture of that. What did you say, Joe? I'm sorry.
So what would be your strategy? Trying to recall back to truth tables. What are we trying to do here? Like, what is the strategy to determine if these two statements are the same?
Yeah, so I would construct a truth table by the columns P, Q, and R,
Right.
and
So
then I'll
let,
just go, just column by column.
QR. Okay. I'll just give you some other column if you so choose to use them. Okay. Okay. So just as a reminder, oops. So yes, we'll have columns for P, Q, and R. I needed more. So just a reminder what we're going to be doing. 1, 2, 3, 4. Let me just concentrate on what I'm doing before I describe it. 5, 6, 7, and 8. Okay. The first thing that we're going to be doing before we even attack any part of the logical statement is we're going to be finding out we're going to be making we want to find every combination of P, Q, and R for true and false. Right. So how we're going to do that, and just as a reminder, our sort of test for that will be 2 to the number of variables. So that's how many rows we need. So how many variables are there? There are 3. So 2 to 3 is equal to 8. We better have 8 rows. Okay. And so I'm going to start by putting true 4 times and then false 4 times. Because half of them are going to be covering all the combinations here, and the other half are going to be covering the same combinations. That's basically what it means. So I have four here. I'm going to do true, true, false, false, true, true, false, false. And this will just alternate, true, false, true, false. Okay. So what would be the next thing that what's our next column, Sebastian?
I would do P and Q.
Yep, perfect. Right, because that's in parentheses. We got to find out what's in parentheses first. So remind me when is P and Q true?
Trying to think. When I get two truths, I think, right?
That's
Oh no,
correct.
no.
No, you're
Yeah,
right.
yeah, oh yeah. That's right.
So that's the only
Yeah.
time it's true, is when P is true and Q is true. Right? Any other comment where if it's false anywhere in P or Q, then the whole thing is false.
Right.
And if you're struggling with that, just think of um, the paper is white and the pen is red. If either one of those is false, then the entire statement is false. My point is, try if you're struggling to remember where's what is and me, what is or me, what is if then. Try to actually create an English sentence in your head that uses that word with like logical statements, and you'll be able to sort of see, okay, if I'm saying the paper is white and the pen is red, but what happens if the pen is blue? Then the whole statement I made is false. It doesn't matter what color the paper was. The pen was not the right color. Anyways. So P and true and true is true. True and true is true. True and false. Oops. True and false is false. True and false is false. False and true is false. False and true is false. False and false is false. False and false is false. Okay. What would be your next column?
I'll do the other set of parentheses. I'll do Q and R.
Okay, we do that. I would.
Or actually we could do P and Q and R right now.
Right,
Actually.
so that we sort of finish off. Otherwise, we're going to be hopping from column to column if we did that way.
Yeah.
And so we'll do, and just make sure that you're keeping track of which one you're doing. That's parentheses P and Q and R. And so all I'm going to be doing is I'm going to be taking this column, P and Q, and ending it with R. So, excuse me, true and true is true. True and false is false. False, 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 and false. Okay? And this sort of makes sense if we just think about it for just a moment. I have three statements and it's all and. The paper is white, the pen is black, my screen is on. All three of those things have to be true, 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 for the whole statement to be true. Right? So Sebastian, as you were pointing out, instead of this is, be careful with doing parentheses first. So to evaluate the second statement, we're going to be doing not P first, we're going to be doing Q and R. Right? So this is true, false, 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 true, false, false, false. And then our P and Q and R. And so this is this column, Q and R, with the first column. So true and true is true. True and false is false. False, 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 and false. And finally, okay, we're being asked, that didn't work out the way I wanted, if this column is the same as this column. That's what really the question is asking us. Okay? So is true equal to true? Sure is. False, false? They're equal, so I'm going to put true. Or you can put like check marks. If you're concerned about this, you can just put sort of checks. Right? We're just checking to see if every line item is the same. And they are. Okay? And so that means we can conclude that P and Q and R is logically equivalent. No, wait. Is that the right statement? Yeah, that was right. Okay. That's because I got worried. That's a congruent symbol. So I was like, why is that the same symbol? That's funny. Okay. So this is what you would write on the test after you did your truth table. And if it was false, if one of these checks didn't check, you would just put a cross through that symbol. Okay. All right. All right. Use the truth table to determine if a statement is a tautology or a contradiction. And so just to remind you guys, a tautology is something that is always true no matter what. And a contradiction is the opposite. It's always false no matter what. All right. This is a pain in the ass.
Hello? There we go.
Oh, you're back? God.
Oh, dude, I'm having so much fun over here. This happened during an exam. I blue screen like 3 times.
Oh, I would be losing my mind. Actually.
Luckily, I am pretty good at macroeconomics, so too scared.
All right, so use the truth table to determine if the statement is true or false. There are only 2 variables, so I only need P and Q. All right.
It's amazing, Joe. You used the straight line tool, and it's definitely not even straight.
I like it though. I like that it's not.
You like that it's not straight? You like things that aren't straight, Joe?
You know,
Yeah.
okay.
It really says something. It really says
This
something about you that your
this
straight lines
conversation
aren't straight.
this
It's a family
conversation.
show.
That's right. That's right. This conversation has taken a turn I was not expecting.
Oh, I'm sorry, Joe.
You know, a turn like something that's not straight. Okay, sorry.
Okay.
Fair enough.
Yeah, Sebastian would know. You know Sebastian works on a bridge? I think bridges are like the least straight thing.
You would know.
I would know. I've seen bridges. Many of them, in fact, and they
You would
crook.
know what's straight and what isn't straight.
I would. I'll tell you, my straight detector is quite significantly
Oh
good.
man.
Unstraight. Not straight. The negation of straight.
Yeah, like a bridge. Look at those lines. I'm serious. Like that just... I can't believe this program thinks those are straight lines.
Well, I saw your last diagram you drew. Maybe you should not be talking.
Which one?
the
I gotta...
the one where we were doing
Oh, the fucking what's it called? Directed graph.
that's right. Yeah, I saw it. Like I felt bad for you. I've been there. 1, 2, 3, 4, 5, 6.
Yeah, at least it didn't look like this.
I don't need this many. God damn it.
I mean, you can tell you're trying to have straight lines, but you just can't.
All right. So again, we
I
have
wasn't trying.
P and Q. So we're just going to find every combination. Again, it's 2 to the number of variables, which is 2 to the second, which is 4. So we better have 4 rows. That's true, true, false, false, true, false, true, false. Okay. And so I am noticing that we're going to need not P and not Q on at some point. So I'm just going to put those here. I'm going to do not P and not Q. So that's false, false, true, true, false, true, false, true. Now I'm going to do what's in the parentheses. So it's P, oops, P and not Q. So that's going to be P and, so this column with this column, true and false is false, true and true is true, false and false is false, false and true is false. Okay. Next thing I'm going to do is not P or Q. Not P or Q. Remind me, Greg, when is an or statement true?
When either parties are true.
Or
So
there's something that you may be missing when you say it that way.
now hold on. If they're both false, it's false.
Correct.
If one's true, it's true. If they're both true, it's true.
Correct.
And
So there you go. Right. So if the first
yeah.
is true, if the second is true, or they're both true, then the statement is true. And so
Sure.
not P or Q. So it's what is it? Did I mess something up? I don't think so. Not P or Q. So false or true is true. False or false is false. True or true is true. True or false is true. And finally, we're going to AND these two together. So that is P or not Q, and not P or Q. So it looks really complicated, but all it is combining these two columns together with an and. So false and true is false, true and false is false, false and true is false, and false and true is false. Since every item here is false, what we have is a contradiction. Any questions?
No.
All right.
What if one of them's true and the rest are false?
Then it's neither a tautology or a contradiction.
Mm-hmm.
All right, I'm going to take a 5-minute break. Go have a quick cigarette. We have 3 more problems to go, and that should look relatively simple. So, but just I'll be back in just a couple minutes, guys. Okay.
Cool. Yeah, I don't know what's up, Sebastian, but my computer's just shitting itself.
What, your laptop?
No, my PC.
So what happens right now when you try to go on it?
It launches up just like any other computer.
And then what happens? Does it turn off? Does you said something about it?
Like right now, if I'm talking with you, I would do nothing, and it would just randomly shut off.
How old is it?
I just changed out parts last year.
And you're running Windows 10, I assume?
Yeah.
Yeah.
No, Windows 64, actually.
Well, I'm thinking Mac. I just say Windows.
No, Mac is even worse. So funny.
What, are you running Windows 98?
I thought it was Windows 6. Is there 98 as well?
Yeah, I think it was a Windows 98.
Yeah, probably that one too. Yeah, I'm running both at the same time. That's probably why it's not working.
With dial-up?
Yep, dial up. You got me. Yeah, I'm still writing in string, trying to search up Google stuff. It's weird.
Yeah, that's weird. I don't know what could be causing us, some sort of flash drive or something, or
My guess is that one of my drivers is not compatible with the new update that Microsoft just launched, because I searched it up and it was like a bunch of people are getting pissed off at them.
when did they do the update? Was it today or a couple days ago?
a couple of days ago.
I think I did that on my Surface.
Yeah, but I just have so many programs, so many drivers that when I have to go and guess which one it is because they won't tell me, it's really frustrating.
Yeah, but when you look for an error inside your system, it should show where the error is on your driver.
Well, that would be a perfect world, but we don't live in a perfect world.
Because every time I had a driver error, it would identify at least what class it was, and then I would just go find the driver or do a driver update or fix my drivers. Because I had a similar issue. Kept getting kicked off like Wi-Fi networks,
Hmm.
and I had to update all my drivers. But then I was getting an error when I was going to my drivers. I was getting like a Bluetooth, and then I went in there and I updated one of my drivers, and it worked fine for a while, but still kind of has that issue.
Yeah.
All right, I'm back.
Okay, let's see. Yeah, Joe, when you were gone, Sebastian was telling me about bridges and how they're actually even more curved than I thought. Something with like their angular trajectory with the rotation of the Earth. And something I've actually thought about now that I've said that is anything really straight? Because when you think about it, if the Earth's curved, isn't everything curved?
Definitely, you're not. So
Dude, how stoned are you right now? That's my question.
No. Here, no, I'm not stoned at all. Now I'm actually thinking about it. Like when we
too
look
many
at
gummies, Greg.
no,
Too many gummies.
no. If we look at a flat, now hear me out. If we look at a flat plane, right, and we're like, wow, this is so big, it looks flat,
If
right?
To answer your question, we live in a flat universe.
I don't
So
think that's
there
true.
is what we do. Um,
I'm joking.
yeah,
It's being difficult.
you're allowed to have incorrect opinions about facts. I don't care.
Okay.
Um, so there are such things as straight lines. All right, so we're just going to generate a truth table for the following statement: not P and Q, or I'm sorry, if not P and Q, then R. So I'm going to do that'd be P, Q, and R. And I'm just thinking out loud how I'm going to approach this. My next column is going to be not P, so I'll put that here. Then I'll do everything on the left-hand side of the conditional. That's not P and Q. I'll go here. And finally, I'll do the whole statement. If not P and Q, then R. All right. Greg, can you tell me how many rows I'm going to need for this?
8.
Correct. So 1, 2.
And hopefully we all know that is because there is a 2 to the exponent of 3 because there's 3 variables. Hopefully you guys know that.
Huh. I didn't know that. Thanks, man.
Oh yeah, my pleasure. Sorry, I'm ordering shoes while playing League while we were talking. So
All right, it's good. I always feel so important when I talk to you, buddy. Nice, nice.
yeah, of course, my pleasure.
PQR, not P, not
I
P
I
and
was getting
Q.
worried. I need to get new running shoes, and this gift card for $100 wasn't working. I was like, wow, I really feel bad for the person.
That's a lot. That's a lot of money for a baby Gap.
I don't know what that means, which means you're an old man. All right, I don't like that.
That's good. Baby Gap. Oh, look at the cute little shoes. We're gonna put them in bronze. All right, so
You know, sorry, I'm a little bit more athletic than you, old people.
I'm sure you are.
I am. Trust me.
True, true. False, false.
Damn it.
Yeah, I have important shit to do, so you can be athletic.
Okay.
True, false, true, false.
Whatever you say.
All right, so Sebastian, just read out to me what would be not P. What do I put here?
False.
Go down the line.
False.
Yeah.
False. False. And then for truth.
Yep.
Let's just do the opposite.
And so, Greg, what would be not P and Q? It would be this fourth column. and the second column. So tell me what to write.
Sorry, excuse me. It would be everything that we would think. Well, that'd be false. That would be false. That would be false. False. True. True. False. False.
Perfect. And so now let's remind ourselves what a conditional is. It's only false, right? So I'm only going to tell you when it's false. Is when I forget what the names of these things are. When the left-hand side is true, and the right-hand side is false. So that's the only time it's false, right? So if false, well, I don't care anymore. Since we're starting with false, it is true. So I'm actually going to do a small table here to show you what I mean by this. So I'm just doing a small table to show you just to remind you guys what a conditional is. So this would be true, true, true. Oh, fuck. False, false, true, false, true, false. So it is only false when the left-hand side is true and the right-hand side is false. So this is false. It is true every other time. And this seems, to me, this always felt counterintuitive. So I'm just reminding you what the values are. Okay. Okay. So Sebastian, what would be false? What is this? If false, then false.
Yeah, that'd be true.
If false, then true.
If false and true, that'd be true.
If false, then false.
Then that's true.
If true, then true.
That's true.
If true, then false.
False.
If false, then true.
If false and true, then that is true.
If false, then false.
And that's true.
Okay, and we're done. That's all it asks us to do is to generate the truth table for this. Good job, guys.
Sweet.
Okay, so we're rewriting each of the statements as a conjunction of two if then statements. And so just to remind you guys what that means, right? So I'm going to write it in symbols, right? A, if and only if B is the same thing as if A then B and if B then A. Which kind of makes sense because the arrows are going both ways. All right. We'll start with you, Greg.
Yeah.
The original statement is this integer is even if and only if it is not odd. So we want to write this as a conjunction of two if-then statements.
1 second. Thank you. So I know what that means. You're wanting me to rewrite it as
Yes. Two conditionals.
to a conditional. If a number is even, if an integer is even, then it is not odd. Is that what you're looking for?
Or you have half of it. It is.
Oh, I see what we're doing. And if an integer is odd, then it is even or something along those lines.
What was the second part of that?
If an integer is odd, then it is not even.
No. So what you were saying. All right. Let's back up. I'm going to erase what we just did. All right. So if you're struggling with this, right, try to memorize the symbols and then write down what A and B is. Right, so A is this integer, or the integer is even, and B is the integer is not odd. Okay? So what I want to do now is I want to fashion a statement if B then A and if B and if B then A. Right, so you had the first half of this right. You did this part correctly. You messed up on the second half of this.
Gotcha.
All right, so I'll rewrite what I shouldn't erase that. Whatever. So this A, so you were saying if the integer is even, then the integer is not odd. And so how would I do if B then A?
If odd, or if the integer is not odd, then it's even.
Perfect. And whenever you're doing this, if the I like this little program. If integer is not odd, then int is even. So what I want to say to you is whenever you're doing a problem like this on the test, when you're done writing it, take a step back and just evaluate, does this statement make sense?
Mm-hmm.
Right? So we know that there's parity with even and odd. So if it's even, then it's not odd. And if it's not odd, then it's even. Does that statement make sense to you? Makes sense to me.
Right.
All right, Sebastian, you're up, sir.
Okay. So for B, we have already if P then Q. So I can't see it. Or if A then B. So in order to get the conjunction, should I just give you the conjunction right now?
Yeah, just tell me what's right.
Yeah. So I'm just gonna add his name in the beginning, so it sounds a little better. I'm gonna say if Bruce passes calculus.
So you're kind of doing this in a different order. Just be careful.
Well,
You're doing B first. But that's
yeah, that's what
fine.
I'm doing. I'm already doing that because we already have the first
No,
part.
no, we don't though, because if and only if is not the same thing as if.
Oh, right. Yeah. So we'll say if Bruce pass. Okay. If Bruce will choose to be a math major, then he passes calculus.
Yeah.
Yeah.
Yeah, I remember when he was grading this, it sounded really effed up, you know?
Yeah, because if we didn't add the Bruce in the first part when we did
All
it,
right. So let me go back to what I was saying before. I think you guys can remember this, right? This is, there's no way for me to, you have to just remember that if and only if is this, it's called a biconditional. It means the arrows are going both ways. So you're just pulling if A then B and if B then A. I can't, you just have to know this statement, okay? Now let's choose, or I said A and B, it doesn't matter what variables you use. So let's just choose our variables before we write anything. That what's up there is correct, right? Bruce will choose to be a math major. And what would B be, Greg?
If he passes calculus.
Right, so I'll even put his name if Bruce passes calculus. Now, if you do this extra little work, then all I have to do is just plug in. I plug in A, B into this statement here. We've already done the first one. If A, well, what is A? Bruce will choose to be a math major. That's what he wrote. Then B, he passed a Coke. What's my next word, Sebastian?
Oh, we're doing the other way now? Sorry.
Yeah. What's my next word?
So if we're gonna do that, we're gonna say if Bruce passes.
Nope.
I mean, if Bruce.
Nope.
What?
You're missing one word. What's the conjunction?
Oh, the and.
Yeah. Thank you. Go ahead.
Yeah. So we'll say if Bruce passes calculus. Then you say then he will choose to be a math major. Yeah.
Perfect. I do, and we're going to come across these kinds of problems a lot. And I did try to recommend to everyone, write down your predicates. Just write them out. This doesn't take much time to write out. Okay, and so like the next problem we have, there are predicates. And in my opinion, taking the extra 15 seconds to write out A and B here you can't get the problem wrong after you do this. You really can't. As long as you remember what is the conjunction of two if then statements. Okay. Last question, number 10. Uh, all right, so we're either going to be using most tolens or most ponens. Okay. So I'm not even going to ask you guys to remember what that means because you actually don't need to know it in order to do this problem. What you do need to do is convert this into sort of predicates and symbols. Okay? So I'll start with you, Greg.
Mhm.
So it's these last three lines, and we don't know what the second one is. What is the sort of the structure? I want the symbols. So
Yeah.
so
I think
what
it's
would you
like
say the
P,
first?
then Q. If not Q, then not P.
So we'll never don't ignore the second one, right? So if P then Q.
Yeah.
Let's ignore that for a second. What is it there for?
Not Q.
Incorrect.
Not P.
Not
Am I right?
correct. All right,
Right.
so
P.
don't freak out. All right, so hey Ilya. Okay, so
Go
if
ahead.
I'm
I don't
saying
remember.
if I'm saying this first line is if P then Q, what is P?
What's dependent on? Sorry. What do you mean
Just
if
ignore
what's
everything.
P's P?
Ignore everything else. You know that this first line is an if then statement, right?
Yes.
Right. So it's if I won't even do that. I'll do P if P then Q. You know that's the form of the first line.
Hmm.
Right. So
Yeah.
now all I'm doing is I'm asking you what is the predicate, and what is the conclusion?
So if
Or
P, then Q. Yeah.
right, so what is P equal to?
Q.
No, listen, no, I mean what is the value of P?
True. Is that what you're trying to get at?
No.
I don't
What is the
know what
predicate?
Oh, you mean like what is it from the question? She did not know the answer.
That's right.
Gotcha.
Thank
Yeah. Yep.
okay. And what is Q?
Uh, she would have asked for help.
Right, so we got the first line down. We don't know what the second line is yet, but we'll get there. All right. Our conclusion here is she did know the answer. So what is that? It's going to be one of these two predicates. So which predicate does that cover?
The first one. P.
Right, P. But it's not P. It's the opposite, right?
Right. So not P, then not Q.
Right. So what has to go here for this to be true?
Not Q. Yes.
Okay.
Gotcha.
Now so all I need to do now, the answer to the question that you'll be putting into the blank is not Q. What is not Q? So it's now, I mean, the way this is worded is a little weird. It's past tense, right? So I'm going to mess with the tense just a little bit here. Instead of would have, I'll say she did not ask for help. Does that make sense?
Yeah. Yep.
Okay, does anyone want to explore? I can come up with another question for the 10 problems that we just did. Do you want me to review?
Let's do this. This is one that is kind of just hard to remember, this one specifically. Let's go ahead and write this down like 10-1, so we know it's for number 10 from exam 1. We can kind of just review those questions once we get back to the very end on Friday or Thursday when we're
That's Saturday.
reviewing.
You're talking about 10.1 and 10.2?
What I'm saying is like, let's remember this one was difficult, and we'll just do this problem 4 days from now when we're almost done studying.
And we'll do a couple of these then. In fact, let's do another one. All right.
Yeah, I have to go, Joe.
Okay, then we'll do it. We'll do it. Okay, Saturday or Sunday, we'll do it. Okay.
Thank you. Yeah. All right, sweet. Thank you for your help, Joe.
Yeah, no problem. Have a good night.
So we're doing tomorrow again, 8:30.
Yep. I mean,
Okay,
unless something drastic comes up, then and I'll let you guys know ahead of time.
So,
Ilya, you came in a little late. We were doing the exam for sorry. Let me just type something out real fast. I'm sorry, 1 second. So this is from exam 1. Were there any questions from exam 1 that you wanted me to go over real quick? I mean, we've already done all 10 of them, but if there was something that you weren't sure of, I could work through a problem with you real fast if you wanted. And I can even pull it up on my screen if you want. Okay, no problem. All right, so we'll be doing this again 8:30, and if you want, I'll be posting a YouTube video to the study session, half hour, something like that. All right, have a great night.